Okay, I wanted to do an example of a type of question you sometimes see in your homework, asking you to convert a system of equations where you have three equations with three unknowns, and they ask you to convert it to a triangular form and to solve if possible. So remember, with triangular form, the idea is you're trying to get one equation in terms of just x, y, and z, one equation in terms of just two variables, and the other in terms of just one variable, but in such a way that you have a triangle. The overall idea, the reasoning behind that is once you know one of the variables, you could plug it back into the one above it, and then plug those two back in to get x, if you already have y and z. So one of the first things that we like to do when trying to do this without matrices is choose a variable to eliminate. So if you notice that there's already one that's already almost isolated, like in equation 3, let me number these, equations 1, 2, and 3. Okay. If you notice in equation 3, we could easily solve for z by dividing by 4 or multiplying the whole thing by 1/4. So if you divide by 4 here and here, you would end up getting that z is equal to -1/4. Okay, so you already have enough information from this point to know that the system is consistent. As soon as you get one of the letters solved for a number, you know that this is a consistent system, and that'll come up again and again, which means because you have one letter solved for already in terms of a number, that this is going to be an independent solution, meaning one-ordered triple in this case. All right, so your solution that you're looking for, your solution set, I should be more clear, does exist because it is a consistent system, and because it's independent, it'll have three numbers for your order triple here, an x, a y, and a z. So for your z here, we know z equals -1/4, and now we're solving for the x, the y, and we already know the z. Okay, so with that in mind, let's continue. The second step, after you've found one of the variables like we already have here, we know z, we now need to find x and y. So what you want to do is typically pick a variable to eliminate, and since we already have noticed that there is an equation 2 here, which already has z eliminated, which is pretty nice when that's already pre-done for us, then what we're going to try to do is keep that equation the way he is. Let me grab another marker here. If I can get this marker off. This top is a little sticky, sorry. So we want to grab an equation that already has, oops, this marker top is not playing with me nicely. Got it. I don't know if you've ever had technical difficulties, but I just did. We want to grab an equation that already has just x and y, and we need to form another one like it with just x and y. Okay, so I noticed that equation 1 has x, y, and z. So typically here, if equation 3 also had x, y, and z, I would work to eliminate the z by maybe elimination or substitution. But in this case, since I've already solved for z, I can plug that back into equation 1. So I'm going to substitute z into equation number 1. And if I do that, I have 4x plus 4y plus 4z. We'll be substituting that -1/4 here, equals 7. And when I do that, equation 1 now should become 4x plus 4y, and 4 times -1/4, that's really 4/1. So we just get -4/4, or -1, equaling 7. Or in other words, we should have 4x plus 4y. If you move -1 to the other side of the equation, solving for just the x and y on one side, we would have 7 plus 1, which is 8. So we have another equation. So notice here we had equation 2, which already had just x and y. Now we have another equation with just x and y. And we're going to put those together to build a new system. With just two variables. So that new system with just two variables is 3x minus 4y equals 32, and 4x plus 4y equals 8. Okay, so what I want to do now after I built my new system is solve the system for x and y if possible. Again, if possible. So to do that, I could use substitution or elimination. I noticed that I already have a really nice setup here where I have a positive 4y and a negative 4y. So I'm going to use that to my advantage. Let me grab another color here. This time it's a little easier. And I'm just going to add these equations together. If I add them together, we will eliminate y. So 3x plus 4x, those like terms give me 7x. These cancel out, which is what I wanted, and 32 plus 8 is 40. Now I can solve for x by dividing both sides by 7. So x is equal to 40 over 7. That's our fraction answer. Of course, you could get a decimal approximation if you so desire. So now we have solved for the x value of the ordered triple, which is 40 over 7. So there's only one more letter to solve for, and that would be y. Now again, you could have gone about this in a different order than we did, but the principles remain the same. You want to solve for one letter at a time, but in order to do that, typically you'll need to find two equations with the same two variables. Excuse me. Okay, so how do we find y? Well, you notice that equation 1 has both x, y, and z, all three variables, whereas equation 2 only had two of those variables. So if I was trying to solve for y, I would pick an equation that only has y and one other variable, like an x, for example. So what I could do really easily is write in the equation 2, the original equation 2, I could replace my x with what I just solved for, which is 40 over 7. Alternatively, in the other equation that we had created here, if you trust it, make sure you hadn't made any mistakes, you could replace your x there with 40 over 7 and solve for y. So either one should work, and then we'll back substitute to get our answer. So let me grab another color like black. So we're going to back substitute to solve for y. So we pick either of the two equations that have just two variables. So I'm going to go back to equation 2, for example, and that was 3x minus 4y equals 32. Okay, and I'm going to replace x with what I know it should equal, 40 over 7. So this new equation 2 should become 3 times something, in this case 40 over 7, minus 4y equals 32. And now if I multiply and isolate y, 3 is really 3 over 1, so I would have 3 times 40, which is 120 over 7 minus 4y equaling 32. Now you could get rid of the fractions, clearing fractions, by multiplying everything by 7. That's an option. Another option is simply to work with the fractions. If I do that, I could, for example, move 4y to the other side by addition, and I could move 32 to the other side by subtraction. I would then have 120, oops, I don't know why I wrote it that way, 120 over 7 minus 32 equals 4y. Almost done. We need to get y by itself, but first let's combine like terms here. If I multiply by 7 over 7 here, let's see what we get. So this will be 14, carry my 1, that's 21. So if you do it this way, you should be getting 210 plus another 14, so 234. Am I correct in that? I believe that's right. 224, I should say. Yeah, that makes more sense. Yeah. And we had the 120 over 7 equals 4y. Okay. So now at this point, what I would like to do is combine my numerators here. 120 minus 224. And what would that give you? Well, 220 minus 120 would just be 100. So we have 104 over 7 equaling 4y. Okay. So at this point, divide by 4 and you'll have y by itself. In other words, multiply by a quarter. And you'll just say 4 goes into 104. Well, 4 goes into 10 2 times, that's 8. Remainder of 2. So now I have 4 going into 24 6 times. So I'm getting 26 over 7 equaling y. Now let's make sure I got my sign right. I think I did notice a sign error here. That was a negative 224, so this should have been a negative, bigger number, right? Negative 26 over 7 would be the correct answer. Okay, make sure that I copied that right. Okay, so now we've finished our ordered triple. Negative 26 over 7 is our y value here. So we had a nice consistent system, and I knew that the minute that I got z equaling a number. Anytime one of the letters equals a number, it's consistent and independent. And then I carefully found the other two variables by creating two equations with just two unknowns, by making sure that the same letter was eliminated from both equations carefully. So I hope that was helpful. If you have any other questions, feel free to reach out to me. Otherwise, happy practicing. And remember, math is not a spectator sport. I'll see you next time.